Program Development Office within the Energy and Environment Directorate. He has more than 35 years of experience developing and managing research, development, and demonstration projects and programs involving government, industry, research, and university partners. Mr. Brouns is a chemical engineer with extensive technical and management experience in the disposition and remediation of chemical and nuclear waste, including processing, disposal, and subsurface cleanup. Mr. Brouns earned his bachelor's and master's degrees in chemical engineering from Washington State University. Tom, thank you so much for being here with us today, and the floor is yours.
Great. Thanks, Don. And thanks to all of you for the opportunity to talk. I was up at my alma mater just about 2 months ago and gave a very similar talk to early career chemical engineering graduates and generally mostly engineering graduates from the Boylan College at WSU, and so I've modified it slightly, but the request to speak was an easy one for me to say yes, because I've been thinking about this topic for quite some time and had a number of opportunities to talk about my experience in going from undergraduate to graduate to engineering and cleanup related work. So anyway, I'll get started here. Let me make sure my slides are shared, and let me know if they pop up.
Yep.
Great. Okay, so I'm gonna talk about my career path, my experience in both engineering general, but much of my career, as you'll see, dealt with environmental cleanup, and so not exclusively, but certainly substantially, and so there are quite a few examples of that I'll share with you.
Cool. I'm going to be in the other lab. I'm on a conference call. Sorry. You don't have any? Yeah. We have.
If you could all please mute yourselves, apart from the speaker. Thank you.
So what I'm going to do is first start talking about my early in my career, my starting point in education, some of the internships I experienced when I was an undergraduate, and then as I moved to P&L and after college and a fairly lengthy set of activities at P&L. After that, I want to talk about kind of some lessons learned. I have critical skills and things that helped me be successful in my career. I'll share with you, and then open it up for Q&A. And hopefully I won't belabor topics that we don't have plenty of time for Q&A, but I have been known to go long, so I'm going to try to keep this moving a little faster than my normal pace. So as you mentioned, Darren, I received my bachelor's degree and master's degree from Washington State University in the chemical engineering program. I had the pleasure or opportunity to start on master's research when I was an undergraduate, my senior year, and that gave me a leg up. And at that time, they don't have this anymore, but at that time they had a program that if you got started early, took some graduate classes as a senior, and you could literally get your master's degree in like a calendar year beyond your bachelor's degree, which was really an opportunity I couldn't pass up. I thought about going back and getting my PhD, but I knew realistically that once I left college and started working, I might struggle to actually get myself back. And so I haven't had the opportunity to do that or had the interest in doing that. A couple other notes. When I was at WSU, I was in what was called at the time the Washington State University Honors Program, which was an opportunity to take some smaller classes in liberal arts and other topics that really helped me balance out some of my writing and communication skills. And one of the things as a senior, I was the president of the AICHE student chapter, which was just an opportunity to kind of get involved in that as an undergraduate, and then get some leadership experience working in that space. The other thing I did, I mentioned getting started on research early as an undergraduate, and I ended up teaming up with an advising professor and working on some bioprocessing research. Got a really nice opportunity to work multidiscipline. I spent half my time over at the vet school learning as an engineer, learning how to keep my hands clean by growing mammalian cells in a lab over there, and then coming back in the engineering side and doing research on a new reactor at the time, a new reactor concept for creating high density mammalian cells in culture in a continuous flow reactor. So that was a great experience, great research experience. It was the start of kind of that multidisciplinary experience that immediately when I get out in the real world working, everything is multidisciplinary. And so I got a little bit of that as an undergraduate and graduate student. I had a number of internships. I'm going to highlight these because I think these were really important for me too. I had the opportunity through personal connections and industry coming on campus and looking for candidates to do internships. A mix of those. One of them, I worked, my first kind of engineering experience was working at the construction of one of the only Northwest nuclear power station, which is here located just north of PNL in Richland, Washington, is what's now called the Energy Northwest Plant Number 2. That was under construction when I was in college and got a chance to work doing, getting experience with engineering and construction related work, which was a great experience, just to get involved in something that was engineering focused. And then the following summer, I got an internship through an on-campus interviewing process with Weyerhaeuser Corporation. I worked at their tech center, which was adjacent to their corporate headquarters in Federal Way, Washington, and then spent most of a summer at a lumber mill in Klamath Falls, Oregon, that was focused on some energy efficiency related work, trying to understand some of the energy consumption in a major production facility. Unfortunately, with changes in the Northwest lumber and environmental impacts, it wasn't too many years after I worked there in the late mid 80s that mill was closed, and but it was a great experience as an undergraduate to work at a large production facility. The last internship I had before I graduated with my bachelor's degree was at Hanford. So this was my kind of exposure to nuclear materials processing and a processing plant, B plant at Hanford, which was one of the major canyon facilities that separated nuclear materials from reprocessed fuel. It was also the place that cesium and strontium was separated from tank waste and put into capsules. So this was just a great experience. Again, an engineering facility. We weren't in production mode, but there was still a lot of operations and maintenance of that facility that gave me exposure to kind of the cleanup mission per se, although this was actually right before officially cleanup started in the DOE complex. When I graduated, I had a number of opportunities, but the most significant one that I ended up taking was an opportunity at Pacific Northwest National Laboratory. One of the reasons I came here is at that time, it was one of the few opportunities I had that might involve bioprocessing or some bio-related stuff that I was particularly interested in because of my graduate work, and so came here in 1987. And just for those of you, I think most of you are probably familiar with PNL, but just to give you a little bit of PNL, it looked a lot different than this when I came in 1987. We were probably less than 2,000 staff, and this pie chart, which kind of shows you the distribution of the work last fiscal year that we do. At that time, most of our work was in defense programs and support to the Hanford site. Today, our Hanford site support is a fraction of that energy and environmental work, and used to be, when I started, was probably 70% of the work we did was related to the Hanford site and both either production or cleanup related missions. PNL is one of the most diversified of the Office of Science laboratories, just because while we're a science lab and a science base underpinning, we have a very diverse portfolio from national security, energy, environment to science. So career paths, when I started at P&L, these not all of these terms are used today in terms of our structure, but there's really three kind of science and engineering paths that I experienced in my career. One is the technical one, which most of us graduating from college are interested in doing technical work or R&D work, and so in that realm, and kind of starting from the earliest part of your career on the top bullets in these columns to maybe the more senior positions. I could have stayed in the technical role and been a researcher, potentially a principal investigator, a process engineer, design engineer, chief engineer, kind of moving up the chain. Some folks in engineering, science and engineering, will move over into kind of a leadership role in the products or programs. So that means you might take a project manager path. Ultimately, that could lead to a collection of projects in a program. You might manage a portfolio of work that's related as a product line manager, or you may focus on your engagement with customers and sponsors, kind of more in a sales and relationship management role. And then the final one I'll mention is the line management, where a lot of our science and engineers go into a leadership role managing people. They may start with a research career, and over time, and they may continue that research career, but some fraction of their time is spent leading a team or a group which is larger than a team, or a department or division, or actually being like a associate lab director or lab director role. So as I entered P&L, I started out in kind of a researcher contributor mode. That's natural for somebody early coming out of college. And I really had an opportunity throughout my career to consider all of these pillars at some point in time. And I'll talk a little bit more kind of what I did, where I went. And so moving on, when I started in 1987 and spent the first 2 or 3 years working as a technical contributor, I had a couple of major projects. They were both Hanford related. One was dealing with like a waste acid recycling process. So acids, a mixture of acids are used to dissolve fuel, and Hanford was late, but still in a production mission right up through about 87. And so there was interest in recycling those acids and reducing the need for fresh acids for the process. I worked on that, doing some experimental work with a low pressure distillation process for cleaning those acids and recycling them. I also worked on a ventilation system upgrade that was being tested for the double shell tanks at Hanford. These were all kind of efforts that P&L was supporting the Hanford site in technology advancement and improvements. I also had the chance, I thought I might have the chance, that's why I came to P&L, was to do something in bioprocessing or biotechnology. And there was a new program started in the mid 80s on hazardous waste cleanup that was run out of Oak Ridge at the time. And I was able to propose some work and with some more senior folks at P&L and win some contracts focused on looking at bioprocessing for treatment of both nuclear and primarily the inorganic, or like nitrates or organics in some of the waste at Hanford. That expanded over several years and ended up with a whole portfolio of bioremediation related projects, which again was pretty early in my career, but there was a growing, the EM cleanup program started in 1989, and there was a large emphasis on technology needed for cleanup. So had lots of opportunity to look at in situ denitrification in groundwater, denitrification of some of the wastewaters at Hanford, organic solvent. Hanford has a large carbon tetrachloride plume, kind of similar to Savannah River's trichloroethylene plume. And so there was work going on how we could biodegrade those contaminants and other technologies for cleanup. And we also started looking at biological interactions with metals and radionuclides, and whether you could use some of those processes for absorbing contaminants. So for several more years, I was proposing a number of different projects, a lot of them in the bioprocessing area, and winning some that went to large scale field demonstrations like the carbon tetrachloride one. It's kind of shocking to me today, but this was over 30 years ago, and we did the first field test of in situ carbon tetrachloride degradation that I think had been done in certainly in the U.S. and maybe in the world very early. Now, ultimately, we determined it wasn't economically practical for the dispersed plume at Hanford, but it led the way and is being considered today for some of the concentrated areas, especially in the soils today, above the groundwater. So there was a shift in the early 1990s where DOE decided to consolidate a bunch of individual projects into larger programs, and that's where I first got introduced to the difference between selling and managing an individual technology or R&D project and the role of managing a larger program or collection of related projects, all focused on kind of a common mission space or problem. And this was early in EM, and they started a couple of demonstration programs where you intersected treatment technologies, characterization technologies, monitoring technologies, drilling technologies. So I ended up spending nearly a decade focused on subsurface remediation projects, but I moved from a project manager for an individual project, research project, or demonstration project to a program manager over a collection of projects, and that were all part of a larger effort to advance technology. And this project at Hanford focused specifically on kind of Hanford as a test site, but there was a companion project at the Savannah River site. So we worked very closely with colleagues at SRNL, all the laboratories who were working in the cleanup area to kind of bring the best of technology and capability to bear on two pretty significant problems of chlorinated solvents and other contaminants in the subsurface. I mentioned, there were technologies at P&L being demonstrated at Savannah River, and Savannah River technologies being demonstrated at Hanford. This role in the subsurface led me ultimately to expand into other areas, and so I ended up serving as the lead for P&L's work on the Yucca Mountain project, which was principally a subsurface performance assessment at the time. That in the work that P&L was doing was mostly about the technical inputs to how you describe the release of contaminants from disposed high-level waste and spent nuclear fuel in a repository. So not only was I focused on kind of the EM cleanup R&D, but also ultimately the repository R&D as essentially a program manager over the P&L work that was supporting with other labs the Yucca Mountain license application. I continued that role as kind of at major programs, but shifted gears in the mid-90s or early 2000s, I should say. I shifted gears and changed my focus to the tank waste. I'd started out working on some tank waste issues, like the double shell tank ventilation system, and got back to that after leaving the subsurface remediation research in the early 2000s, and started working on a similar program, but focused on tank waste technology. And this was a national program addressing technology needs at Savannah River, Hanford, Idaho, West Valley, and even the Oak Ridge Reservation. And all of that led to some robotic technology deployment, treatment technology efforts, a light-duty utility arm that was deployed at several of the sites built off of for those of you who remember the space shuttle, the Spar Aerospace designed the space shuttle arm that was used for all of the space shuttles, and we had the opportunity to work with Spar Aerospace to design an arm that could be deployed into the tanks at Hanford, Idaho, and Oak Ridge. So this was a major program on tank waste that I was involved in the leadership of, and then ultimately leading that program up through 2005. And it delivered a lot of technology for cleanup at multiple sites. And after that program went away, I started expanding my role in kind of major certain key programs and projects. I was embedded for a time in the tank operations contractor at Hanford. So basically on loan from P&L, serving in a strategic planning role with the site contractor that's responsible for the actual tank farm operations. And then following that, there was a major effort in an issue that was up at the secretarial level, an issue with the design basis for the Hanford vitrification plant. And I spent a couple of years building off of my subsurface background, leading a project to collect seismic data underneath the plant, below the ground, about 1,500 feet below the plant, to make sure that the seismic basis for the plant's design was adequate. And that process was another very multidisciplinary program with seismologists and universities and industry to drill boreholes, collect seismic data with this large University of Texas at Austin vibrator truck that thumps the ground, creating a seismic wave that's then measured downhole. And this was interesting. It was a bit out of my, other than as a project manager and dealing with the subsurface, it was substantially out of my comfort zone, and the fact that I had really never dealt with, seismic signals and data collection and that type of thing. And so it was a great experience, but it was particularly important because the construction of the WTP at Hanford had halted because of concerns from the Defense Board on the design basis, earthquake. And in a short, less than 2 years, we were able to collect the data that helped resolve the issue and get construction restarted at the WTP. Kind of the final shift in my career was kind of moving from projects and larger programs to one of leading the relationship management of all of our work, supporting the Office of Environmental Management, the Office of Legacy Management, and for a period of time, the Office of Radioactive Waste, or Office of Civilian Radioactive Waste Management, or RW. And I have served that role off and on, and roles like it since about 2008. And I'll speak a little bit more about a couple of those efforts. So one of the aspects of that, what we call a sector or a sector director at P&L, is I serve as the kind of single point of contact for our sponsors in our environmental management space, which is DOE EM and DOE LM, or Environmental Management and Legacy Management. So for many years, I served as the kind of single point of contact, working with my colleagues and with our federal colleagues to make sure that P&L's work was focused on the priorities that EM needed us working on. And about 2010, I was asked to do a similar role, but instead of with EM, it was with the Fossil Energy Office in DOE. And then the idea here was that fossil energy was facing, technically it was dealing with some very similar things as EM, not in terms of cleanup, but process technology for producing clean, stripping carbon dioxide or processing coal in ways that prevent environmental impact, and drilling and characterizing the subsurface to support carbon sequestration and or more effective oil and gas retrieval from the subsurface. So it was a subsurface and above ground processing, much like environmental management is largely about subsurface environmental remediation and processing of stored waste. So I spent about 6 years working in the fossil energy business, learning a bunch of different sponsors, working with DOE headquarters, with the National Energy Technology Laboratory, and kind of leading programmatically our work supporting during this time, mostly carbon capture and carbon sequestration, but also gasification, coal conversion to other products and that type of work. And so that kind of extended my role in a relationship management, a client engagement standpoint. And in 2016, I was asked to come back into the environmental management field because of some challenges that were happening that kind of required my re-engagement. So I came back in as kind of a mega project manager for a couple of years, and then ultimately took over the same role I'd had previously in terms of leading our environmental management programs. So with that, I'm going to pause a second. I'm going to shift gears a little bit and just give you a little bit of a sense of Hanford's cleanup challenges, which I've spent a large part of my career on decades ago, and even most recently in terms of Hanford cleanup. I'm sure many of you are well familiar with Hanford cleanup, but I just want to give you like a 3-minute quick run through of what's been happening and what's happening today, and kind of the impact that I feel like my career touched on throughout many decades of work at Hanford. And so first and foremost, if you don't know, Hanford's cleanup mission really is about thousands of waste sites, hundreds of facilities, both intentional and unintentional discharges of contaminants to the soil, large subsurface groundwater plumes and soil plumes, and then of course concentrated liquids, solids stored in aging underground tanks. And the problem at Hanford has kind of been parsed into the river corridor, the central plateau, and then in particular the inner area in yellow of the central plateau, where most of the processing facilities and the tank waste is stored, and the waste treatment plant is housed. And of course, all of this waste really derived from the production of nuclear materials at Hanford, starting in 1944 with the production reactors along the river. Sorry, I'm just going to use my laser pointer here, and hopefully you can see that. So the production reactors, 9 of them, that are all housed along the river at Hanford. And from those production reactors, spent fuel was processed through one of 4 different facilities and processes at Hanford. Some of the first of the wastes went to T plant, and then B plant, and S plant, and then ultimately Purex facility. And one of the biggest challenges with Hanford waste, tank waste, is that unlike every other site in the country, Hanford had the first full-scale production plutonium production reactor and the first large-scale processing facilities that processed irradiated fuel. And so the first many of years used some very inefficient processes, bismuth phosphate in T plant and B plant, and a redox flow sheet. And those processes generated a lot more waste than the Purex process, which of course has been the workhorse for many, many decades for plutonium production. So because of that, the waste generated from each of these processes was significantly different and stored in double shell and single shell tanks and blended with other wastes. And so the waste mixtures at Hanford for tank waste are really much more complex than other sites. And so we have a combination of salt cake, sludge, and supernatant in those tanks, stored in about 54 million gallons, stored in now less than 177 tanks, since some of them have been retrieved, but widely varying waste compositions. And as you probably know, the waste treatment plant, this section of the Hanford inner area or Central Plateau, this facility, the low activity waste vitrification facility, has started up as of mid-October and is processing low activity tank waste, supernate, that's had cesium and strontium removed and producing glass logs. The high level waste facility right here is restarted construction and is moving towards completion within the next decade, so that the high level fraction sludges can also be vitrified. And in the west area, there's efforts to bring on some pretreatment capability to remove cesium and strontium from supernates over there, or dissolved salt cakes that form supernate that will be separated, and that waste will likely in the near term be grouted and disposed off-site, whereas glass from the LAW facility will be disposed at the integrated disposal facility, which is located here. And this kind of gives you in very detailed, still high level, but quite detailed, the general process flow sheet for Hanford waste and the tank waste coming from tank farms, moving through low activity waste, moving through cesium removal to the LAW facility, which then creates a glass product going to IDF. In the future, the sludges from these tanks will be characterized, staged, and go to high level waste facility, vitrified, and stored for final disposal in a yet to be determined repository. And as I mentioned, some of the tank waste, especially in west area, is going to come through some form of alternative LAW treatment or supplemental treatment that will go off-site for disposal ultimately. And that's what's depicted here with DF LAW, the progress on bringing that LAW facility online, as well as the pretreatment to get you there. And and then ultimately we'll see grout waste being produced in a few years also, and being sent offsite for low-level waste disposal. So that concludes kind of the overview of my career development path, and I just wanted to wrap up with some lessons learned and kind of critical skills based on my experience in moving from college to early career in research to later career in managing research programs. First, I mentioned before, multidisciplinary teams. I think the key I've learned is that big and interesting problems require multidisciplinary solutions and multidisciplinary teams. And my success depended on working with a diverse set of people with different disciplines, different capabilities, in some small and some very large teams, to try to develop the solutions that could be deployed to solve the challenges we were addressing. So I think some colleges, some universities do a better job of creating an opportunity for that multidisciplinary. I think CRESP activities in particular do a really nice job of bringing together the diversity of expertise and capability. But in my own experience, some of the challenges I worked on really combined the capabilities from a wide range of disciplines. And and I'm probably missing one key one early in my career that I'm missing from this list is social scientists, and the work we did with stakeholders, especially kind of the predecessor work to the Hanford Advisory Board, where we started engaging the regulators and stakeholders in what did they want to learn about technology, what were their values and important aspects of technology that could help us understand what we needed to to do in our research programs to collect data that would make them comfortable with those technologies being viable solutions. In much of my area of work, I stepped outside of my normal comfort zone of kind of chemical engineering or traditional chemical engineering, and worked at least a decade in my early career with a wide mix of folks that I had, frankly, little experience with from college in terms of geologists, hydrologists, geochemists, civil and mechanical engineers, computer science, biology, and sociology. So my career path went from coming out of kind of a process engineering background, and suddenly I was spending more of my time in working with folks characterizing the subsurface, which was helpful to have a very broad technical background and be able to work with a lot of folks in disciplines I wasn't particularly familiar with, but that really expanded my knowledge and skill set as I, early in my career, as I moved into other areas. In my case, I think my chemical engineering training made me valuable across many technical areas. There's a joke about chemical engineers that we're neither good engineers or chemists, but more jack of all trades. And so I think a broad science and engineering background, no matter what engineering field it is gives one a pretty broad perspective, and to be able to apply that in the disciplines of environmental cleanup in particular. The other thing I wanted to speak to, another key area, is that I think certainly in a university setting, from my experience, is a different culture than working in, say, EM, in a lab, or in industry, in a high hazard business, where safety and quality really need to be really sacred in terms of not compromising in either space, making that safety part of your regular personal routine so that it's ingrained in you, and you apply safety skills in a challenging or questioning attitude all the time in everything you do, whether it's at home or whether it's in the lab or on your way from home to work or to school. Always being diligent to protect yourself and protect those around you. You learn quickly in a lab environment how absolutely critical it is to be very cautious, careful, and thinking about what can happen and planning for that. And I just a few other photographs here. So, for example, when I was working on the seismic boreholes for the waste treatment plant, the challenge here was that we were working in drilling deep boreholes, and drilling is an inherently dangerous occupation. We were located 30 feet off the base mat of the high-level waste facility in a very congested, busy construction site, and had to operate safely in that environment with a lot of stuff around us. And so that was about mid-career for me, frankly, but it was a really eye-opening experience, how important it is to have just the discipline, the expectation of risk and understanding of risk, and the reporting culture to make sure everybody is planning their work professionally, effectively, day in and day out. And from a quality standpoint, that's another one I learned is firsthand, was that small errors can erode the trust and reputation pretty quickly. And so, keeping an eye on what the work you're doing, the calculations being done, making sure things are peer reviewed carefully and checked. It's really tough to rebuild your reputation after you experience some error or concern about the quality or adequacy of the work you're doing. And while I wasn't involved in the example here of state ecology director rebuking DOE for their solid waste EIS, it was an example of one during my time where some miscommunication and what should have been minor errors became really a major issue for the reputation of that. And that's a multi-million-dollar document that was literally canceled and restarted all over because of errors and issues in the document. So, and then I have some examples from my work again on WTP where we were very concerned about making sure that we had, quality pedigree of the data we were collecting because it was so important to the restart of the construction. We had 2,000 construction workers out of work and all being driven by the seismic uncertainty and needing to provide quality data quickly to assure that issues could be resolved, the secretary could approve the plant restart and construction and get 2,000 people back to work. And the very first report we issued, we said, well, we need to make sure this is the easiest of the three major reports we're going to issue. It was the least complex of all of them. We thought, well, let's use this as an example to see whether, let's do a good peer review, make sure that we got no issues. There's traceability of every number in this report to the actual data collected. And we started looking at it and put a couple eyes on it and said, well, there's errors here. This table in section 2 doesn't match the data in section 3. And we had to retract the draft and did full eyes. I think we had 5 people independently reviewing this report from front to back just to make sure that there was full traceability of every data point in it. And it was an eye-opener for me to realize that something so simple as just a data report, that it could so easily go wrong, and how much attention needs to be spent to make sure that it's solid and data is collected. Fortunately, we caught it on the easiest of the 3 reports, fixed our processes, got the culture change where we were very, very diligent with the analysis and got the 2 more out the door and got the plant restarted. So build reviews into your work, welcome others' critiques of your work and make sure that you're really putting out a quality product that's going to withstand the test of time. And I think this is close to the end of mine recommendations, but the other area was communication skills. And for those of you who are engineers, you probably recognize that we get a bad rap for poor communication skills generally, just a general critique of engineering students and engineers in general. I'm not sure that's fair, but what I learned was a real strength in written, oral, and interpersonal communication is critical to my success. And so take every opportunity you can, even if it's uncomfortable, to speak in front of the public, speak in front of large groups, write, and continue practicing writing. And every bit you do will make you a better communicator with your peers and with your customers. And last one, think about the big picture and think about your work and being able to explain how it fits into the grand scheme, into the big picture. So I always ask folks to really, the first time they start talking about whatever they're working on, just start with the big picture. What's the challenge you're trying to solve, and how does the work you're doing either partially or fully address that problem? And with that, I will stop and give the rest of the time back for Q&A.
Thank you so much, Tom. It was truly inspiring to hear how you navigated those, inflection points within your career and were able to move forward and succeed. We have some time for um, questions. Please either write them in the chat or unmute yourself. Any questions? All right. In the meantime, I'll ask my question. So I was, it was very interesting how I think you said in the period of 2006, 2007, you were working in this seismic realm, and it was like a very novel field for you. And back in 2006, I think you wouldn't really find, any like YouTube lectures or like an LLM to ask, basic questions about the process. So how did you navigate this novelty in terms of gaining the knowledge? Did you go to the libraries or did you ask the right people for for the basic educational purposes?
Yeah, that's a great question, Darn. So so first of all, the reason I got pulled into it was from more from a project management perspective as opposed to my technical strengths. But as you probably know, it's really hard to manage a team working on a really important problem if you don't understand the basics of the problem or how the problem needs to be solved. And this was clearly, I mean, I understood drilling technology. I understood some of the basic characterization things because the same things you do for a seismic borehole, you're going to do for, sample collection from different strata in the subsurface and that type of stuff. But fortunately, I had some people at P&L that were experts in the geology that had been involved in some characterization of deep geologic features under the Hanford site back in, and if you've been around long enough, you might remember that there were quite a number of sites being considered for a nuclear waste repository back in the day, and in the late 70s and early 80s, Hanford's basalt layers that underlie the site were considered one of the isolation venues for deep geologic repository. So we still had people around at that time that had worked that early characterization. They weren't looking at seismic issues as much as they were looking at, the characteristics of the basalt. But anyway, so I had a few experts that were still around. Some retired that came back to help. Others that I was able to pull from. One person who had been involved in seismic hazard analysis, that was kind of my go-to person. But I really ended up surrounding myself with an entire team of contractors and others that had the expertise, so didn't rely so much. I got enough of a basic. I did pull up some reference materials and try to study it. For example, there's a famous method, the SHAC process, which is seismic hazard analysis. It's basically the Bible for doing seismic hazard analysis that I think was prepared in part by maybe Berkeley and Livermore and some other folks for DOE and for industry. So there were some guiding documents that were available that I was introduced to get a flavor for it. But I'll be honest with you, much of that stuff was just purely Greek to me because it was my first exposure to the probabilistic hazard analysis, which seemed, from somebody that did most of my work in very deterministic ways, probabilistic hazard analysis seemed very obtuse to me, and I didn't try to understand it all. I just accepted the fact that I was not going to understand everything, but I had enough understanding to drive the the staff and the project to completion. So really good question.
Thanks. Any other questions from the audience?
I have a question. My name is Viviana from Georgia Tech, and thank you for sharing your career path. And looking back, which key decision in your career open the most opportunities for you at Hanford or PNNL?
Yeah, great question, Bibiana. There were several. I'm not sure which one was the greatest, but I'll the decision that was the greatest. But I will tell you, it probably, there was a point in my time in my career where I was working probably 10 or 15, 12 years in. I was working on subsurface cleanup related stuff. I've been doing that for most of my early career. And the program I was working on realized that we weren't going to have a significant role in the future, and so I needed to consider doing something different. The program as we envisioned it or were involved in it at the time was transitioning, and so I needed to go find something else to do. And I had two opportunities at the time, and one was to stay in an area that was really focused on the environmental remediation. I could move into at the time at the lab. It was like a product line. Meant all the folks doing work in subsurface, I would be kind of leading them programmatically. And the other option was to completely shares and go focusing on the tank waste processing, which I had just barely touched when I was very early in my career. I hadn't worked on it for more than 12 years or so. And I struggled with that decision because my comfort was in the subsurface. I'd been working in it so long, and staying there and taking that trajectory towards this kind of subsurface environmental remediation product line and kind of owning our portfolio and helping expand that, or shifting gears to a program that in a technical area I'd spent little of my career in. And I struggled with that decision and said to myself, should I take the easy or the more challenging? And I made the decision at the time that, I would learn more. I would be out of my comfort zone, but I would meet new people. I would learn new things. I would probably have an opportunity to see things that I wouldn't have seen if I had taken the more comfortable position to just keep doing things in what I had been working on. And that, I think that really opened up a lot more opportunity for me. So, yeah, and so I didn't put that in my advice, but I'd say be careful about doing what's comfortable, and maybe think about opportunities that are going to challenge you to learn and do something different and meet new people.
All right, last call for questions. All right, thank you, Tom, for a great talk. This is actually our final speaker series seminar of the year. We're very grateful for the participation, and we look forward to our upcoming series of year 2026. Thanks again for attending, and happy holidays.
Yeah, happy holidays to you too. Thank you. Thanks for the invitation.
Thank you.
Thanks for joining.
You.
Thank you.
Hi, Jody. How are you doing? I will see you tomorrow. You're muted. I thought maybe you were muted on purpose because you were doing something.
I was
flying out
muted
tonight for Vanderbilt.
You are? Okay. I hope it's a little warmer for you. It's supposed to warm up over the next couple of days. It's been so cold.
No, it's very cold here.
Is it?
We're not
Yeah.
that far away, I think.
That's true. It's just a 4-hour car ride. It's not that far.
Yeah. I should have probably, I don't know. It's on my borderline between driving and flying, but I'm flying tonight. So that gives me the ability to work all day, so.
Yeah, well, you could work. That's true. You could work or you could drive. It is true. I used to live in Atlanta, so
Oh, okay.
I know, and we're sending thank to you. So
Yes. Yeah, I dropped in on her seminar. So
dissertation?
thanks for,
Oh, you
yes,
did?
thanks. I didn't stay the whole time, but I was appreciated you sharing it, and I did drop in. I was going to send you an email, but well, thank you for rounding up the troops,
You're welcome.
which was okay, I think. You know,
You know,
we were above 20, so it was like okay, but
considering-
you worked, you had to work for that, I think. So thank you.
But considering the time of year it is and
The
that a
bad
lot of
time.
people are done, yeah, I mean,
Yeah, we should. That wasn't the good timing, but it's okay.
And also-
but you did it. You got
well, thank
over
you.
20,
And also
so.
a lot of people who might have been on the call from CRESP are en route. So, you know.
Well,
what are we
yeah,
gonna
and
do?
I didn't even think about that, but now you're doing this today. But I did just want to mention, so when you sent the email reminder, the most recent one, I clicked on it. It took me
Yes.
to a previous Teams meeting.
Yes, it did. Yes, I know.
But then I went to the calendar invitation and it took me here.
Right.
But then I tried to join from my phone and I went to the calendar invitation
And it
and
wouldn't
that
took you
took me to the
Rodney's
previous
Teams.
meeting. So
Okay.
there's something, I don't know, something weird. It wasn't
What I'm
just that
gonna
you
do
sent
is
the
I'm
wrong
gonna
link.
exit out of all of them and start fresh with the
Yeah.
next one.
Well, yeah, and I think, but I also wonder, does it depend which account I'm logged in under or something, and does it switch me to Vanderbilt? I don't know. Teams is so confusing. So
Oh, that's
I
a
just
good
I just wanted to let you know, but maybe other people also let you know, because I saw some people
Yeah,
on
there
the
were
other
a few
call.
people, right? So like, Matt Weber said, so is it canceled? And I sent him the link from
Oh,
the
you did.
calendar
Okay. 'Cause I didn't
invite.
see Matt here. I saw that Nick and Viviana were on the other one, but they were on this. Okay. So anyway,
So I said to him, he's still speaking if you're so inclined, but it's okay if you don't. What are you gonna do?
Yeah.
But
yeah. Okay.
okay,
That's
all right. I'll see you tomorrow. Safe travels.
Thank you.
Okay,
Take care.
bye.
See you tomorrow.
Bye.
Bye. Thank you.